Hello everyone, I am Dipshika from Bodhi Academy, and in this video we are going to start with a new chapter from the Mathematics 7th Standard Mathematics textbook, NCERT textbook, chapter number 6, that is the triangle and its properties. Okay, let's start with the chapter. Okay, in earlier classes you all must have learned about the triangle. Okay, the classification of triangle, that is based on the sides. Before that you must be knowing what are sides, what are angles, and what are the vertices. Okay, like for example, suppose this one triangle is given, that is the triangle ABC, correct? And the sides of this triangle, these are AB, BC, this is the second side, and the third side, it is AC. Okay, now what the angles, the angle that this triangle consists of, the angle ABC, angle ACB, and angle BAC. Understood? So there are three. And what are those? What are the vertices? This A, B, and C. These are the three vertices of this particular triangle. In earlier classes we have learned. Okay, and we also know the classification of triangles based on the sides and angles, correct? That is based on sides there are three types of triangles, that is scalene triangles, isosceles triangle, and the equilateral triangle. And based on angles there are three: acute angle, obtuse angles, and the right angle triangles. Okay, so um, okay, we'll try this activity. Okay, so what first, try this. Okay, write the 6 elements of triangle ABC. So here what they have told us, they have told us to write the 6 elements of this triangle ABC. Okay, we have already discussed over here 6 elements. Which are those? That is the 3 sides and the 3 angles, correct? The angle, the sides will be we'll draw one here. It looks like samosa, na? Okay, consider this is a triangle. Okay, you have to draw with the help of ruler. Okay, so six elements they have told, right? So the 3 sides and the 3 angles. So sides, which are the sides of this triangle? Side AB, side BC, and side CA, correct? And the angles, angle ABC, angle BCA, and angle CAB. These are the 3 angles. Okay, so the next thing they have, what they have asked, that is write the opposites to the vertex Q of triangle PQR. Okay, PQR. Okay, and in the question what they have mentioned, that side opposite to the vertex Q. This is one vertex, right? So side opposite to this vertex, that is PR. This side is opposite to this vertex, correct? So that is, the answer is PR. It is side they have asked. Okay, okay. So in the next question what they have asked, that is angle opposite to the side LM of triangle LMN. First we have to draw the triangle. Okay, without that we can't tell. So draw the triangle LMN. And what is the question? That angle opposite to the side LM. this side they have asked, okay, side LM, which angle is opposite to this side, that is angle N. Okay, then what is the third question? Vertex opposite to the side RT of triangle RST. RST. Okay, so here what they have asked, the vertex opposite to the side RT. Which vertex? That is RS. RT is this side and the opposite to RT is the S vertex. Okay, the answer is S. Okay. Okay, so what they have told in the third question, look at figure 6.2 and classify each of the triangles according to its sides and angles. Okay, so this is figure 6.2 and we have to classify the triangles, you know, based on their sides and angles. So here you can classify it. Okay, now we'll start with a chapter, that is medians of a triangle. Okay, what you do, you know, take a piece of paper, and on that paper, you know, we'll start with the chapter, that is medians of a triangle. The topic, this is topic, not a chapter name. Okay, so what do, you know, take a piece of paper and draw one triangle. Okay, then cut it with the help of scissor. Okay, in the shape of this triangle, then fold this triangle. Okay, how it will look? It will look something like this. Okay, fold it and then again you open it. Okay, again you open it. What you will find, you know, it will be like this. It will divide the triangle like this. Okay, you will find one line. Okay, so like this you do. Okay, and the line that will you find, you know, that which is a perpendicular this line, suppose we'll name this triangle as ABC. Okay, yeah, ABC. So this line, you know, that is a perpendicular bisector of the side BC. It will perpendicularly, it will bisect this side, that is BC. Understood? And this line we have to join it from the vertex A. Okay, we have to join it with the help of ruler and pencil from A to the point which bisect the line side BC. Okay, and this line, that is called as the median, which perpendicularly bisect the side of the triangle. So let's see over here. This is called as the median of the triangle. Yeah. Understood what is median? Okay. Now we'll see something called as altitudes of a triangle. Okay. Okay. So under this, altitudes of a triangle. Okay, let's suppose consider this as a triangle. Okay, and this is suppose height of the triangle, which is given as, which is perpendicular. It looks like samosa, but consider it as triangle. Okay, you draw on your book with the help of a ruler. I can't draw it here with the help of a ruler. Okay, so you draw it properly. This, suppose consider this as a height of the triangle. We'll see in the 3D picture here. see, this is a triangle which is a ABC, and consider this dotted line as the height of the triangle, the height of the distance from the vertex A to the base, that is the base of the triangle here, that is BC. Okay. Okay. So there can be many lines also, from this point which bisect this particular base BC. It can be from here also, here, like this. It can be so many lines. Okay, so out of all this, which is a perfect altitude of a triangle? Okay, so an altitude that has a one end point at the vertex of a triangle and the other line containing the opposite side though each vertex can altitude. Okay, this can be altitude. And which is the correct altitude, which is a perpendicular to the side BC? This is an altitude of this triangle. Understood? That is basically the height. Altitude is height. So let's now solve this thing, discuss and write. How many altitudes can a triangle have? Okay, so here, see here what happens. From where we draw the altitude? From the vertex opposite to the side BC, correct? Okay, so from this vertex we can draw one. What about this vertex? From this vertex we can draw an altitude to the side opposite to this vertex C, which is the side opposite to the vertex C, that is AB, correct? So we can also draw altitude from AC to the side AB. Okay, like this. Wait, we'll draw later. Here we'll draw. Okay, so here we have drawn. Okay, this is an altitude, correct, of a triangle. Okay, this altitude we have drawn, which is bisecting the side BC. From this altitude we have drawn from this vertex, that is A. Okay, from A to the side opposite to this vertex. Now from this vertex we can also draw one altitude which is opposite to its side, and the opposite of vertex C, the side opposite to the vertex C, that is AB. So from this we'll draw it here. Okay, and this vertex we can draw also an altitude from this vertex to the side opposite to vertex B, that is AC. So altogether, what was the question they have asked us? That is, how many altitudes can a triangle have? So from this we can say that triangles can have 3 altitudes. How many altitudes? 3 altitudes. Okay, why? Because there are 3 vertices. Triangle consists of because triangle consists of 3 vertices. Okay, because triangle consists of 3 vertices, so there are 3 altitudes. Understood? Then draw rough sketches of altitudes from A to BC, side BC of the following triangle. So here they have given 3 triangles, that is acute angle, right angle and obtuse angle. So what they have told us, that to draw altitude sketch from vertex A to the side BC, only one altitude they have told us. Okay, so how we can draw? We have to draw line from the vertex A to the which is bisecting the side BC. Okay, from here the A bisecting the BC. So here on this line only the altitude will be present, this only. Okay, we'll draw it. Okay, wait. First is given as a acute angle, correct? An angle, the name as the triangle is named as A, B and C. So what they have told us, to draw a altitude from A which is bisecting the side BC. So it will be like this. Okay. Then the second is given as something like this, that is a right angle triangle. Okay. So here the C is given here, A is given here and B is given. So here from vertex A to the side BC. So here this so the here the altitude will be like this only. Okay. And one obtuse angle that is given. Okay, this is C, A and B. Okay, so here A bisecting the BC, we can't draw it like this, it should be perpendicular, correct? So here it will be like this, it should be perpendicular to the side BC. Okay, like this it will come. Will an altitude always lie in the interior of a triangle? If you think this that this need not be true, draw a rough sketch to show a such case. Just now we have seen in this case what they are saying, will an altitude always lie in the interior? Here it is in case of this acute angle, it lies in the interior of a triangle, here on the side of the triangle, and here it is outside the triangle, right? Exteriorly it is present. So what will the answer? No, an altitude does not always lie in the interior of a triangle. Example is the obtuse angle. Can you think of a triangle in which two altitudes of the triangle are two of its sides? Yes. Okay, so that is in case of right angle triangle. So here you can see there are two vertices, two altitudes of the triangle are two of its sides. So here one altitude from the vertex A bisecting the BC, that is this on one side, and other from the vertex B, that is vertex B. Okay, from vertex B if you draw, okay, which is bisecting the side AC, then it will be like that on the side of the triangle only. So that in that case the right angle triangle is the answer. Can the altitude and median be same for a triangle? Yes, in case of an equilateral triangle. Okay, in case of an equilateral triangle, here this is an suppose equilateral where all the sides of a triangle are same. In that case the median and the altitude can be same. Here the median is this middle point and the altitude is same. Okay, so here both can be same, altitude as well as the median can be same in case of equilateral triangle. Okay, so we'll solve this exercise, that is exercise 6.1. Okay, okay, so what is given, here in triangle PQR, D is the midpoint of QR. Okay, in the triangle PQR, D is the midpoint of QR, they have told us. Okay, so we have to tell them what they have asked. Side PM is dash, this is the side PM. What is that? Side PM is the, okay, D is the midpoint, that means D is the median. What is PM? PM is an altitude, okay, of vertex Q which is to the opposite side of its, that is PR. sorry, PM is a wait, sorry, I'm sorry. PM is an altitude. Okay, it's an altitude for vertex P to the opposite side, that is QR. Understood? So what is PD? PD what? That is the median. Okay, of the vertex P to the opposite side again QR. So PD is the median. This is an altitude, and its QM is equal to MR. Just think that is QM is equal to MR. No, correct, because QM is not equal to MR, because M is not a midpoint, it's an altitude. Midpoint is D, so Q is equal to D and D is equal to R. Okay, QD is equal to DR, but not QM is equal to MR, because this is not a median point. Okay, so this is not no, QM is not equal to MR. Okay, so now draw rough sketches for the following. Okay, so we'll do it here. Okay, what they have told, draw rough sketches for the following, that is triangle ABC, A, B and C. BE is a median. So what they have, yeah, BE. So from vertex B we have to draw a median, because they have told the name of the median as BE. So we have to draw it from B. Okay, so we'll name here it as A. So this is the answer. We have drawn a median from B, vertex B. Why we have drawn from vertex B? Because they have already mentioned the name, that is BE. If they have told us that, if they have been told us that if you have to draw from CE, or you have, yeah, then we have to draw it from here. Okay, here, and we have to mark it here as E. Okay, then the next question they have asked, that is in triangle PQR, P, okay, we'll first draw it. In triangle PQR, okay, PQ, this PQ and PR, they are altitudes of the triangle. Okay, PQ and PR, they are altitudes of a triangle. So we have to draw it in such a way, you know, this is an imaginary, just I have drawn. What they have told that is in, we have to draw in such a manner that the PQ and QR, they are the altitudes. Okay, so how you will draw it? It is where the here they have told what they have told us to, you know, to draw the altitudes on the side of a triangle, and that is possible only in case of right angle triangle. We have previously seen that, correct? So we have to draw here directly the right angle triangle. Okay, right angle triangle, because altitudes on sides are possible only on the right angle triangle. Okay, and PQ and PR, right? So we have to PQ and PR, so this should be P. Okay, and this can be Q, or this can be Q also, or that can be R also, no problem, but this should be P, and this is right angle triangle. So the altitude from vertex Q will be this on the side of this triangle, and from R it will be on this side. So the altitudes are on the sides of a triangle. Okay, then the second they have drawn told us that in triangle PQR, PQ and PR are altitudes of a triangle. Okay, we have done. In triangle XYZ, YL is an altitude in the exterior of a triangle. So here they have told us that in triangle XYZ we have to draw YL, that is an altitude that is in the exterior of a triangle. Okay, so that is possible in the case of obtuse angle. We have already seen over here, right? So in the case of obtuse angle, we can obtuse triangle, we can draw the altitudes in the exterior part. Okay, whereas on the sides of a triangle, in case of this right angle triangle, which we have already drawn here. So here we have to draw one obtuse angle type. This is an obtuse angle, okay, in triangle XYZ, that is correct. Okay, YL. Okay, wait, YL they have told na to draw altitude YL. So this should be Y and this should be Z. Okay, so from Y we have to draw altitude, okay, exteriorly. This is an altitude. So you have to remember, okay, if they have told you all to draw altitude from exterior, then it is obtuse angle. On the side, then it is right angle. Within the triangle, then it is acute angle. Okay, you have to remember it. Okay, so yeah, thank you so much. In the next class we will cover the next topic, that is exterior angle of a triangle and its property. Okay, yeah, practice this at home. If you like the video, then please hit the like button. Do share with your friends. Okay, like, subscribe, and yeah, thank you so much for watching the video.